Welcome everyone. I'm Richard. I like legacy code. I also do a fun thing called a health check, meaning I look at, 4 million lines of code and I try to figure out within 3 weeks how that works, what are the problems, how do you get out of there. And afterwards, I sometimes get asked to fix stuff, which is what this talk is about. So, who here works in legacy code? Not anymore, okay. Who thinks their work is valuable? Okay, good. So usually I always give a speech about, hey, your work is valuable because the code you're working on, if it wasn't valuable, someone would have deleted it.
Please delete me with that code.
Okay. I see. So we're doing a bit of self-help here. I see. Anonymous legacy code. Okay. So, domain rediscovery patterns for legacy code. So, the whole idea behind this talk is the question of domain evident code, meaning you look at the code and the domain speaks back to you. The problem is that some domains are not very evident. You go there, you create, this is the first pattern, you create a code tag cloud. You look at all the names, not the types, the names initialized in the code, and you map it to a tag cloud, and you're like, what? I mean, the center, right? Is it stringly or strongly typed?
Yes.
Yeah. And you can clearly see here there's some modeling to be done, because if my biggest thing is string and my next biggest thing is object, and if it's just a generic exception, there's nothing domain evident in this. And if you look a bit at the classes and how they connect, you also see, okay, this one is also not very evident. It's like, oh, like lots of things I don't understand with random arrows between them, and you're like, oh, okay, what's this? So when you start a project, you usually have the problem that, code is not testable, like at all. You're very fearful of change. If you write tests, they become blockers in some way. You have this general lack of domain. A change here breaks there, and you're like, why? And yeah, the business feels this innovation jam, like a traffic jam, but for innovation. They want 16 billion features, and you deliver like 1 per year. And finally, when will it be done? And there's someone there and just, hey, come on, next week, right? Next week. And the problem is, I mean, you want to fix this, right? Because you work there every day, so you kind of want to clean up your own workplace. But where do you even start? I see I made a mistake. I should have put
Also a list of deceased developers.
a list of disease develop. Okay, let's not go there. Let's not go too morbid. So the second pattern I want to talk about is instead of looking at long lists with too many entries, you should map your code. So this is a shameless plug, top right corner, but it's free and open source, so don't worry about it. So let's imagine you take some file, some service, whatever, and you map that as a building. Meaning you take the area from top, and that becomes how large the building is. And that's lines of code, for example. On the height, you put the complexity, the cyclomatic complexity, meaning how many decisions does your code make. And on the color, you put, for example, the number of authors. It's not the only metric. And if you do that, and you map it for your whole code base, you get this, a code map. And the interesting part is, if you look at the metrics on the bottom, you have lines of code, cyclomatic complexity, and the color now is churn, meaning how often has the file been changed. You can get that from Git easily. We built parsers for this and everything. So if you look at the top left corner, you see this one. It's got lots of code, lots of complexity, and it's changed all the time. And oh, hooray, it's called module service. It's like, what does it do? And you're like, okay, obviously this is a good target to start at. Because it's changed all the time, meaning, hey, if we fix that, if we make it smaller, everyone will profit. But what does it do? So the next pattern is, you should start at the edge. You should look at your controllers or at your repositories. I personally think it's easier to start at the controllers because they sometimes put nice things in the controllers and you see a bit more of the intention. And you look at the module service and you go up and you come to, for example, the data ops controller and you're like, hey, okay, I can start there, right? Because the intentions are a bit more clear. And then you go down into the code of the data ops control and you see this nice piece. You're like, case RNT, okay, I don't know. Case RTN, whatever. Case CRT, I don't know. But some things down there might be a bit clear already, and some things are like, I don't know, that's applesauce. It's like, you give it a name, like applesauce. It's from Arlo Belshi, the idea. And this name, applesauce, already communicates to you, hey, I don't know what it does, but I'll make it obvious that I don't know what it does. Obviously with the intention to actually put the name there over time. And some things in the bottom are kind of obvious, and how about we name them? So the one is for creating book, and the other one is for creating a broadcast. So what that is, this extraction into separate classes, is all about making the controller humble. So you make the controller humble, meaning you extract everything from the controller which is hard to test into a separate class which is easy to test. By the way, where is it? There, the link for the pattern. And then you look at your extracted class, and you see, okay, so every line sort of does different things. Line 4 access external service, line 5 does something weird, raw access of repository, and you're like, okay, yeah, that's a SQL injection happening right there. I think if I just continue talking, this will stop. And now you can see that every line of the controller has a different purpose. I apologize. After drinking half a liter of water, apparently I'm still thirsty. There we go. So every line has a different purpose. Every line has a different layer. It's either presentation, application, meaning checking for permissions, for example, domain, the thing you paid for, or there we go, or data. Data can be repositories, but it can also be like line 4. It can be accessing an external service. Okay. But the one thing you shouldn't do is be like, oh, okay, down there is a lot of stuff. How about we move it up there? How about we change the order and put stuff that's in the same layer right next to each other? And that's a very, very good source of bugs, and you won't notice them. Why? Because there's a concept behind that. It's an execution order that needs to be kept. We call that connaissance of execution order, and if you violate it without tests, you will fall in your face. But there's one thing you can do. It's not about reordering, but you can extract stuff. And you can do this without tests because you have a great IDE, and you're probably using Rider or IntelliJ, and damn right, you have a refactoring for this, and that one is your friend. And you don't need tests for that. Why? Because it's automated. It will do the right thing for you very, very safely. And what did we do here? We extracted so-called ports. And these ports are the thing that the domain needs. We extracted the ISBN client, and we extracted the books, the repository. If you extract it as an interface, that means in the next step, you can actually inject it into the constructor. And because it's an interface, you can give in your tests, you can put a separate implementation into that. An implementation that only works in your test, that doesn't access outside. And you can configure it for your tests differently. Now you have a testable class. What does it give you? Well, you went from this in the beginning, where everything's kind of mixed, to the humble object, then to defining things that your domain needs or your application needs, and finally to configure ports. So, we've now split it, but we cannot reorder it without tests. So, tests. Can we test a system we do not understand? No, yes, no, yes, no, yes. Okay, audience, you're great. Yeah, you can, actually. You can do something to characterize your classes, or a characterization test. If you have this applesauce class, and you put in, down here, you put it, for example, in a file, you put this example here, foo and 42 and true and whatever, returns none in 2024. But from it can be a return statement, it can be console log, whatever. But if you capture that, you will see you've now covered the first 4 lines with random parameters. And if you tweak it a bit, you can see, okay, if I put in this, I cover the next lines. And if I put in that, I cover the next lines. Meaning, given enough, sometimes random and sometimes very dedicated input that you decided on, you will actually cover enough. There's a library that does this. It's called approval tests. But it doesn't really matter if you use it or not. The idea is always the same. You store all these inputs, and you store the outputs that it generates. You don't know if these outputs make sense. You just store it. And you capture it. And why does it help you? To characterize a snapshot of your system. You don't know why, but the test will tell you when you refactor. What does refactoring mean? Well, changing the structure without changing behavior. That means all the things you captured before, all these outputs, as long as they stay exactly the same for the same inputs, then you are refactoring. If they change, meaning if the tests become red, then you're not refactoring anymore, and then you're in a dangerous territory. The problem is, at some point, you want to change the behavior. You want to be like, oh, okay, this behavior doesn't make sense. It should actually blah, 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 blah. That's when they stop you. And that's when we actually have to go into new territory and actually build tests that capture the intention. But and then you have to delete the characterization test. But until then, they will help you refactoring and make sense of what the system actually does. So they're super helpful to start. Later on, you need to delete them. In addition to this, how do you come up with characterization tests? Well, one is the random approach. The other one is the inverse object mother. So you start the system, and it will probably crash because your database is empty. There's nothing in it. You analyze what the errors are. The system actually needs. You write that down in code. You restart the system, and it will crash again. But it will be crashing one step later. And then you put that into code again, what you need to create the state. And finally, at some point, you will actually start the system, and you can click through your first use case, and then it will crash again, and you will put the right state in there, and blah, 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 blah. How does it look like in code? Well, for example, like this. In your main method, you have this one. Sorry, it should be one characterization. First you create user, system crashes, okay. You need one author, okay, system crashes. You need one book, system crashes, blah, 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 right? Until it finally doesn't. And that's just a characterization. It doesn't really tell you why you need that, but you need it for a system to start. So, where are we? Code is testable. Awesome. We have characterized some behavior. What is missing? Well, where's the domain? We haven't done anything for the domain. So the one thing you can do, which is super, super tiny, but I find super, super helpful, is to make small changes which bring big knowledge boost. One of these things is actually giving your IDs a type. So before that it was string, later it's user ID or book ID or whatever. What does it help you? Well, first of all, you can always see what the right type is, and you cannot mix them up. So in line 6, you can see I can pass in any string. I could even pass in the user ID, even though I want to get a book. But line 9, because the type system prevents it, I cannot pass in the wrong ID. Doesn't work. But you can also do that for units of measure, like meters, seconds, money, whatever. And if you're in a cool language like C#, you will also get operator overloading, and you can actually put in the nice plus sign. You will also get that in Kotlin, by the way. Next. By this point, you probably have some form of grouping. Your Apple sources, you're like, oh, okay, these things seem to be doing the same thing. I will put them in Apple source package or project or whatever. And you can look at them and you're like, okay, great. Does it make sense? Are the right things together? I don't know. I suggest you next look a bit at entity ownership. Meaning, you grab all the, if you're in SQL, you grab all the selects and joins and put them as read statements. You grab all the insert, updates, and deletes, put them as writes. And then you can map this. And you can look at who reads and who writes books. And you can see that you have all these scattered reads, which are the red dots. Now, why are they problematic? Because the entity you're writing, the book, it has a contract. For example, every book has to have an author. And if you have like 3 different ways to write the book in different places, you don't know if they all follow the same contract, if they all ensure the book has an author. I mean, you can look at each individual code, but normally you should put them all together. And for the reads, they're problematic because when you have them in so many different places, the question quickly becomes, do they actually need the same data? Or do they need different forms of data? You know, one might need two fields of the book, and the other one might need two completely different fields of the book. And that can be your indication to split that, to take one book and make two different versions of it, depending on which component needs the data. So with that, you can bound the entity ownership. Only one write location, and depending where you're reading, you should split based on the parameters the actual method needs. Then you can continue. By now, you've moved stuff around a bit with your helpful IDE. And you will probably notice patterns to emerge. And you will see, cool, I can write down these patterns as code. Let's see this ArcUnit. You have a great .NET version of it. You can say very interesting stuff. You can say no classes should depend on classes that reside in package service. That can be an architecture rule. And by writing this with ArcUnit, you can put a test around it, meaning all these pesky cross dependencies that you notice and you like, they shouldn't be there. You write an architecture rule of what should be. Then you say, okay, freeze anything that violates these rules. And now, if new violations come, they will actually throw an exception, meaning make the test red, but the old ones won't hinder you. And of course, you can also make that without the freeze. Now, the great part is, as soon as you have all these violations, again, you can map them. And you can sort of do this North Star architecture. Where do I want to go? And you can be like, oh, okay, cool. I have lots of violations here and there. Where am I going to put in features next? Maybe I should fix the architecture violations because I will need to go here. Maybe I should fix them there before. So, code is testable. We have characterized behavior, and we now have domain clusters. Now we're going to jump a bit here, because probably your boss is knocking on your door now. What have you been doing the last, I don't know, 4 weeks? Like, So, it's like, hey, dude, come on, when will it be done? And you're like, oh, yeah, see, that's a complicated thing. Because we are in certain components, we have a lot of uncertainty. We don't really know where in here it will be done. You have this overhead of legacy. And depending on how refactored the code is, you can be much more certain of your estimates. While in the beginning, you're like, I don't know. You could even theoretically put zero in there, like, no idea at all. So he will be like, when will it be done? And you're like, well, you know, the legacy is the reason why I cannot really tell you. But if you give me more time to refactor, we can turn it into that. We can make the corridor smaller. How can you measure that? Well, here comes in your whole team. Because you can colorize based on the predictability. You can make up, you can write down what your rules are. These ones are just suggestions in 3 categories: in structure, in behavior, and in service level agreements. So, are there architecture rules enforced? Yes or no? Do I still have things that are violating this? Yes or no? If I still have things that are violating, X. Is the component testable? Green. Do I have enough characterization test coverage? Green. Now, these ones are simple checkboxes. So if one of them becomes true, you just say 1, and if the second one comes true, you say 2. And you can just say, okay, 2 out of 10 are true. That means red. That means something like 10% predictability. And now you can do this for every component. And you can do like, okay, so patron is very red, book is orangey, inventory is more yellowy. And guess what? You can also communicate and you can say like, okay, but patron is the thing we're working on because we know we want to put new features into that one. And since the last time we talked, we've already improved it. Arrow up. Book has gone down a bit. Be transparent about that one. And we've got a slight quality dip, but it's going to be fine. And inventory, maybe it's good enough, maybe it's super bad, but for some reason you just said, okay, we don't need to change it. We're just going to call it locked or frozen. It's also okay. You don't need to fix everything. Now that's for stakeholders. For your product owner, maybe he needs something more deeper. And you can put in the colorize the capabilities. How good is search? How good is quote? How good is the search in the inventory? You can actually put that one level deeper and actually colorize that one as well. Then you can plan a bit more detailed. Sorry. And the cool part is, by addressing these three layers, structure, behavior, and service layer agreement, you will unearth the domain. And because you do that, you will fix the predictability. So it's a win-win. Great. So we have quality views now. What about change here breaks there? That's a great one. So guess what? We can map that. So imagine you look at the Git history and you see, okay, file A is always committed together with file B and C. Then you can see, okay, there seems to be some form of temporal coupling. This one thing here is for some reason coupled to B and C. So you can map that. Like you can see that rent service is always committed together with all these tiny little files. So there seems to be a lot of temporal coupling going on. But there's no compile time dependency. So nothing in your type system will give you this information. You can get it from Git. By the way, yes, we have that in Codecata. Yes, it's still free, but it's completely stolen from your code is a crime scene. If you've seen that one, Adam Thornhill is amazing. Look him up. Code scene is also pretty cool. So, what does it mean? Well, A, C, and B, you can see, they're with the import statement, they're statically coupled. But you have all these temporal coupling, which is invisible unless you map it. And all of that is caused by something called connaissance. What is connaissance? Yes, thank you for asking. Two elements are connaissance if there's at least one possible change to A that requires a change to B in order to maintain overall correctness. That seems super obvious because if you call a function somewhere, then the name of the function where you call it and the name of the function where it's declared has to be the same. IntelliJ will help you with that, right? Or Rider will help you with that. It's a bit less obvious in other cases. For example, if you have a SQL table, right? Your select star from table name. Your table name has to be the same as the one in your actual database. Otherwise, this won't work. So that's connaissance of name, pretty obvious. Connaissance of type, also pretty obvious. The type has to be the same where you declare it and where you use it. Why are these obvious? Well, because they're easy for your brain. It's a bit more tricky when you have connaissance of meaning. If you have a function that accepts a Boolean, the interpretation of the true has to be the same where you put it in there and where you actually inside the function. If you put in true and inside the function you flip the interpretation, well, you've broken connaissance of meaning. But you also have the same for strings and for null and whatnot. And all of these are bad. And there's actually 6 more of these connaissance levels, but we don't have time to get into them. What you have to remember is, up there is the explicit domain, and down there is the implicit domain, or the hidden domain. Up there is very cheap to change something, and down there is very expensive to change. The connaissance of execution order is I think level 6. So you should always refactor upstairs. That means connaissance guides refactoring. If you look at this piece of code, you can see you actually interpret the string irregular. And that means where you set regular has to be interpreted the same way as where you actually read it. You have this connaissance of meaning. Down here for the amount 25. Why does it guide you? Well, if you look up what is above connaissance of meaning, you have connaissance of name and connaissance of type. So you can put in, for example, instead of a string, you can put in an enum, movie type. Or you could use a sealed interface. That's a Java thing, I forgot what it's called in C#. Or you could put in generally just an interface movie. No, it's much better because it's it cannot the two interpretations cannot change that easily. But again, what you do depends a bit on the team. All you know is if you have connaissance of meaning, you should go upwards to type or name. And down there for the number, very, very easy one is to put in a constant. And this constant, where you set it and where you use it, is always going to be, or it's much easier to keep that in sync than if you just put in a random number of 25. So we went from connaissance of meaning to connaissance of name. So the connaissance helps you because if two things have a strong connaissance between each other, you can either reduce strength, meaning go down to name or type. You can increase locality. The two things you don't know how to reduce the strength. If they're in the same function, it's much easier to keep them in sync. If they're same in same package, also in the same namespace as well. Or you can just say, okay, I have to lock this. It's the way it is. I'm not allowed to change these anymore. It's also okay. You can just say, okay, it's going to be stable from now on. No change, and also okay. If this one is interesting to you, we have an article about that one. Down there in the corner. I can also send you the link afterwards if you're interested. So, where does that bring us? Well, we've decoupled some with the help of connaissance and temporal coupling. Now, tests that become blockers. The problem is that tests done in a special way can cement the structure and actually block your progress. So you have one test that accesses class book, the constructor. It initializes the book. And then you have n further tests that also do the same thing. That means the number of tests that use the constructor of book will actually cement the design of this constructor because you very, very much don't want to change the constructor when you have 1,000 tests that create a book. And if it's a core entity, then you are much, much less willing to do so as well. So it's the redundancy of this. And you have the same thing for classes somewhere in your code base. If you have n tests for this class and you want to remove the functionality from this class and put it somewhere else, you are not motivated to do so because it will break 1,000 tests that use this class. So what do I suggest instead? Briefly, I instead suggest you go outside in and you use something I call a test TSL. Instead of directly initializing all this stuff, instead of directly accessing stuff, we go outside in from the outside. Outside in from the outside. Yeah, we go outside in, and we use an abstraction in between our test, our test and our initialization of production code. What does it look like? Well, first we say, I want an integration test, and build me a DSL. Then we use a DSL to create a book. Doesn't matter what parameters the book has, we just want a book. And this allows us to actually change the constructor of book very, very flexibly, because it's not the test that initializes the book, it's the DSL. Then we want a user and a role, we call it a bundle, and this user should have the permission can rent book. Again, we don't know how it gets in there, the DSL will take care of that. Why does it help us? Well, because if the design of the user or the book or whatever changes, we just have to fix that in our DSL. But all the application, all of our tests can actually stay the same. Then we save our state to database, to the secondary ports. We configure the thing we want to actually test, which is the renting. And then we rent book. Now, this seems awfully complicated. Why put something in between? Well, because in your legacy code, maybe you have, for example, some code in your database, some stored procedure that is called. At some point, you want to get that out of there. If you write it this way, with the DSL in between, and at some point you've now taken it out of your database and actually moved it into a domain, the thing that was before in the stored procedures, now actually C# code. Well, at that point, you can change one line, and then it becomes a unit test. And you just do that. And that means all the tests you've built before are still valid, and they are just now unit tests. See that? Integration test, unit test. Done. I see it too often that these tests become blockers. That's why I encourage you to think about this one. I wrote about this in German magazine, Java Aktuell, but it's also on my blog, the first part. So, outside in test via DSL, almost done. The innovation jam. Now, we have actually created a lot of help already. We've already refactored a bit. We have some structures, some characterization tests, we have some unit tests now. And now we can safely work towards our goal. We can go from that, which was initial state, to we've separated out, we've changed the order. And we can change the order because now the tests are actually no longer characterization tests, but actually unit tests. And they actually reflect what we want, what we think the domain should do. And yeah, this one will probably call to something else at some point. We can also show technical improvements. We can again, map it. We can be like, oh, okay, cool. So here, we've reduced the complexity by this amount. Here, we've increased the complexity a bit, but it was necessary because it's new functionality. Here we've decreased complexity, there, and there as well. The domain will say hello, and suddenly it will be about a patron and a book. I mean, work is not done in everything. We still have UUID, which is weirdly big in here. We now are much closer to predictable innovation. Depending on where we work, it's going to be less of a range when we're done. And the business will be very happy about this one. Now, we could talk even more about patterns. I love mapping stuff. In case you're very interested in CodeKarta, here's the QR code. And I would be super happy if you would give CodeKarta a star. Also, you can download it. And if you have Sonar, you can already map your code. I think it's like 2 lines to actually execute that. And you can ask me about all these topics that are interesting to you. If you want to, you can send me an email and ask me for the slides. And if you want to, you can also talk to me for like say something like 30 minutes or 60 if you have more needs. No problem at all. And oh wait, I have to move into position. There we go. And if you want some small code cutters, because they are 3D printable, you can come up here and talk to me. Thank you.